I am not quite ready, and I think I already went live. I'm doing uh, what's today? This is Q&A Friday. I don't even know what's being shown on the screen, if anything. Um, sorry about that. I hit a button and I shouldn't have. All right, I'm going to see if I can do this. Control V. Control V. Save. I'm going to hit I'm going to hit save, and I'm going to hit start broadcast. All right. Hopefully that's working. Welcome to Q&A Friday. All right, William Snyder. Hey, sorry about that. I hit a button that I didn't want to hit. I'm a little late. I wanted to go live at 12. I'm 6 minutes late because I was on the phone, and I didn't know how long that was going to be actually, and it turned out not too bad. All right, so I should be live on 1, 2, 3, 4, 5, 6, 7 channels. Felix Sandoval, hola, buenas tardes. Tomás y todos los demás. Muy bien, ¿cómo está, Felix? And I'm out of coffee, but that's okay. I think I can do that for this period of time. Okay, so I got to get my bearings together because it's Q&A. It's Q&A Friday on Thursday. Remember to what? Subscribe. Remember to subscribe. Hit the thumbs up. If you got to hit the thumbs down, hit it twice. Don't forget about IAEI's YouTube site either. Remember that and check that one out. Today I got 3 key topics. I want to talk about circuit breakers in a panel board. I want to talk about heat rise and AFCI trip codes. That's another big biggin. Here in West by God, Virginia, we say biggin. I am looking for. Here it is. All right. So first step. Okay, so first step, I was doing some homework here. William Snyder, hey, I have a question. I ran into breakers that were mildew resistant. Are there breakers that are listed or rated for a damp location? Not that I am aware of, Mr. Snyder. Let's do this. Before I get into the heat thing, because that's a good question. Okay, we know what the standard is UL 489. So UL 489 is the standard for molded case circuit breakers. 489B deals with circuit breakers for use in photovoltaic systems. Let's do this. You said, Mr. Snyder, William, you said mildew. DEW. I'm searching for mildew in the UL standard. And there's nothing in the UL standard that deals with mildew. Let's do this. Mildew resistant. And you know what? I think maybe I'd love to know. I'd love to see the okay. You know what? Except whenever you go to an Eaton site, always accept all cookies. We love cookies. Chocolate chip cookies, sugar cookies. I don't care what kind of cookies it is. We love cookies. So we have a line of marine circuit breakers. Not Marina, the Navy. The Navy uses our circuit breakers. Eaton's, so expect quality and dependability from the Eaton's Navy and Marine molded case circuit breakers. Navy and Marine circuit breakers are vibration tested, fire and moisture resistant, and treated to resist corrosion. Users will appreciate the shock and impact resistance and the easy on-site customization and installation capabilities. These circuit breakers are qualified to Navy mil-spec or Marine specifications. See, we all learn something together because we have questions and we explore answers together. Look at this. It says qualified to Navy and mil-spec UPL, blah, blah, blah. Parts are treated for resist corrosion. Fungus moisture resistant treatments for severe atmospheres are available as modifications. So they can do those types of modifications. And our Marine circuit breakers, which are for the Navy, do have these types of capabilities. Now, I would say, William, that you probably wouldn't pay for some of these circuit breakers because of all the treatment that they go through and whatnot. Your decision. So here's another thing. Here's just as an FYI, and I would say I would argue that in many cases, when you look at say this circuit breaker, depending upon the location you're going to be putting it in, or you're planning or thinking of putting it in. You may want to put these into different locations simply because of the environment. I'm going to get him a little later. Plug-in mounting bases provide the ability to. So take a look at the Marine breakers. Take a look at the solutions there from in some of the treatments that we have there. I'm going to do some homework on whether or not you can buy circuit breakers. Now, when you say that's it, the other ones are dry location rated. I would say you can't put a circuit breaker in a wet location. So I'm having a little heartburn by saying the others are dry location, implying that these are wet location. You're not going to be able to put these in a wet location. You're not going to spray water on these circuit breakers. I think when they say mold or mildew resistant and things like that, they say moisture resistant. They say are both fire and so it says shock resistant molded cases made of reinforced glass filled thermosetting plastic provide very high mechanical strength, shock and impact resistance, are both fire and moisture resistant, and provide excellent dielectric characteristics. So what that means in my mind, think about a circuit breaker. You've got the lugs and everything else that on the end of the circuit breaker. That does not mean that the assembly and in its entirety is moisture resistant. No, you still have to put these in dry locations. And the enclosure, remember, they're going to be mounted either in an enclosure or in a panel board. And remember, a panel board's only that chassis. And then you're going to put the panel board in an enclosure. So and the enclosure has to have a 3R rating or the appropriate rating. And depending upon the environment that you're going to put the circuit breaker in, you've got to put it in an enclosure. Now we can do things like treat choose the thermoplastics or the thermosets that we use to make those devices to give them some added capabilities from shock resistance, mechanical strength for the environment. Think about a boat or a ship or something that's going to be that has to withstand seismic verifications, seismic events. We may have to do certain things, or you may find it attractive for your application to have some of these qualities, but that doesn't mean you're going to put it in a wet location. So that's my point there, William. And I know Hopefully I did not screw that one up. I'm sure I'll hear about it if I did. But check out the marine circuit breakers. If they're used on the Navy ships and whatnot, they got to be doggone good. And there's a video there, Circuit Breakers Explained, from Dan Carnevale. I mixed Dan and Carn, and I got Don. So Dan Carnevale did a great job talking about circuit breakers. I'm not sure if he talks about the marine breakers in there or not, but check that out. Reliability of commercial-grade Eaton's Navy and Marine molded case circuit breakers offer a rugged and robust design, providing a peace of mind. Peace of mind. All right, so, and we have our whole portfolio out there. But whenever they talk about mold resistance or higher strength, it's the casing. It's that thermoset, thermoplastic, whatever we're using for the construction of the circuit breaker. But that does, again, you still have to put that in an enclosure that has to be rated for the environment. All right. So you put these breakers into an enclosure, right? And we know one of the hardest tests to pass from a standards and codes and from a standards perspective in making assemblies and whatnot is that heat rise. They put temperature sensors inside and on certain locations on the circuit breakers, and they look for the temperature rise as it carries current, and it can't exceed certain thresholds. And I'm telling you, that's why we have the 80 C, the 80% versus 100% rating, right? So you take a circuit breaker and you always, whenever you do your load calculations for continuous loads, we add 1.25. Why do we add 1.25? We add 1.25 because current through conductors generates heat, and I may need a larger conductor to wick some of that heat off. So when we add 1.25 to the load, so if it's 100 amps worth of load continuous, I take 1.25 times 100, I get 125 amps. I put 125 amps worth of conductor on the lug instead of 100 amps worth of conductor on the lug. That gives me a larger conductor size to help deal with the heat inside of that enclosure or on that termination. So that's basically what's going on from a temperature perspective. Now, back in the day, when AFCIs were first on the market, you recall, and I might have one here. All right. So what did we do inside of these devices? We added a CT. Okay, and we also, you'll see this black wire that's going through here, and you'll see a bare copper conductor right there. Okay, that bare copper conductor is actually even, and this one's not a copper conductor, this is standard thermomagnetic breaker. You'll see that stranded wire right here. And what is that? That's a flexible conductor inside of this circuit breaker that connects the contacts, which are moving, with the termination, right? So if you think about you're actually physically moving an arm, and if I had a conductor on this arm that was solid, it wouldn't be able to move, right? Or if it did move, I'd have to have it hinged somewhere, but then all those little hinge points that have to carry current, I wouldn't be able to maintain a very good connection. And what would I get? Heat. And that's typically ungood in an electrical installation. So, and that's a technical term, ungood. So what we do is we added a circuit board in here, which is a brain. We have a CT, we've got a wire, you've got that flexible conductor. Now, if you think about the location of this wire, the location, this is a standard thermomagnetic circuit breaker. The flexible wire that connects the lug with the element. Man, I had that backwards. that the flexible wire, which is right here, that connects the arm. You see it moving, right? Hopefully you see it moving. Okay, that flexible conductor connects the contact with the bimetal and your instantaneous that's on that gives you the thermal magnetic capabilities of a circuit breaker. Now that conductor and the routing of that conductor within the enclosure, you can imagine it's going to get warmer. It's not as thick and heavy as the rest of the components in there. The routing of that, because of the construction of putting a circuit board inside of an AFCI, you'll notice the conductor that goes through the CT. Let me get my Keith Laughlin thinking pin. Okay, so there's a conductor. There's your sensor. There's your CT. Here is your lug. Here's a CT. Here is a lug up here too. So you got my hot conductor lug. I got my neutral. My hot conductor comes down through this sensor. And look, this black conductor is flexible and it comes up and goes to the rest of the standard thermomagnetic circuit breaker. And look where it routes. It routes right here, which is, there's your handle. And this is, there's your conductor. That conductor is going to get a little warm, and it is where? It's right here on the face of this circuit breaker. So what typically happens? What do? We take a panel board cover off. We have these circuit breakers there, and what's the first thing we do? We put our finger here, and we go, wow, that's warm. That's pretty warm. Or we'll hit it with a thermal scan, and we'll see what looks like a hot spot right here. Now, if you are unaware of how these things are constructed and what's inside, when you hit that thermal gun on there, you're going to see what you think is a hot, you think it's an overheating element or something that's wrong with the circuit breaker, but really it's not, because it's just how it's constructed. And you're looking at that little conductor that's inside the actual unit, because remember, a thermal gun, when you do a thermal, you're going to see the heat on top of this plastic, which is going to disperse, right? It's going to heat, and then it's going to get cooler as it goes away, but you're going to have a little spot right here on the face. And so people would use an infrared gun, and they would look at the face of these breakers. And if it was an AFCI circuit breaker, that conductor is right there at the front. If it's a standard thermomagnetic circuit breaker, that little conductor is back here in the middle of the circuit breaker. So it's not near the front. It has a little bit of time for the heat to dissipate and not heat up one specific spot on the circuit breaker. So you take the case of an AFCI that's doing its job, finding a problem in the circuit, and it's tripping. And then you say, wow, I'm trying to troubleshoot this, and you take the thing off, and you say, well, this is the breaker, and you put your finger on it, and you go, wow, it's warm. And then maybe you put your finger on the other circuit breakers, and you say, wow, those are warm. And then what do? You run to the truck. You run to the truck, and you grab your little thermal thing, and you play Kojak, right? And you're that police officer on Interstate 79, and you are going to get the temperature of that circuit breaker. And what do? You see this hot spot right there, and you say, well, there's a problem. And really, it's not a problem. And really, the problem is out there in the circuit that the device was finding. So, the temperature of the unit, and let's just talk about the temperature of the circuit breaker when you look at it. It's going to be driven by where this is routed. Now, I know one of the things that we did, and this is an earlier design, because of this, and beating up the design engineers on these products, saying, look, people are complaining about this, and they're like, well, they're like, well, Tom, there's nothing I can do. I mean, it's just a standard. I mean, everybody's got the same type of an issue. I mean, you have a little conductor in there. It passes all the UL tests and everything is fine. It doesn't impact the performance of the device. It's just a perception thing. I'm like, well, yeah. And so what did we do? Well, we rerouted that, and I think our latest design, and well, I've been out of the product line for long enough that technology has taken over, and I'm sure that a lot of what I remember about these designs has changed. But I know at one iteration they relocated the routing of that conductor, and everybody was like, "Wow, what did you do to your breakers? You know they're cooler." And you know what I say? I say, hey, yeah, we addressed your concern. We made a design change. What did we do? We rerouted the conductor. Didn't do anything different. Same length of a conductor, just a different route through the breaker. But it's hard to explain that to people sometimes, and sometimes people just don't want to hear that explanation. They like the easy answer that it's hot and there's a problem, and then you say there's no problem. It works fine. And then when all of a sudden that little hotspot went away for them, you say, yeah, you know what, we fixed the problem. So anyway, that's a little bit of history and a little bit of discussion around the temperature of an individual unit. Now, take that concept and say, look, based on history of these devices, I know that these things are like warmer than the standard thermomagnetic breaker perceptually. And they'll say, when I have a thermomag breaker next to an AFCI, and then I have another thermomag breaker, and then I have an AFCI, and they'll actually say, I put a circuit breaker in between the AFCIs because they say it makes them run cooler. And I just chuckle. If it works for you, it works for you. There are some individuals, say in sports, right? They'll say, I have to, who was it? There's a sports football guy who says he had to take a bubble bath before every game on Sunday. And it was his Saturday night thing. He took his bubble bath. And if he didn't take his bubble bath, they would lose the game or something like that. So he had to take his bubble bath, and there was an incident that happened, and the reason that I learned about the story was he was talking about, I can't remember who it was, talking about the incident and that he didn't get his bubble bath, and he thought it was like, oh my gosh, what am I going to do? I didn't get my bubble bath, or I didn't. Everybody has that lucky towel whenever they go golfing or whatever it is, right? If it makes you feel good to put a standard circuit breaker in between two AFCIs, and it works for you and you feel good about it, well, then God bless you, do it. But I'm telling you, it does not do anything with regard to the performance of the devices. Okay? Putting multiple circuit breakers, multiple AFCIs in a panel board, will it be a little warmer? It's probably a little bit warmer because you do have a microprocessor in there. And that probably adds a little bit more heat to the situation. I've not done the math in that regard, but I'm telling you that from a heat rise perspective, from a performance perspective, from a circuitry perspective, a detection of arcing faults, the thermomagnetic protection does not impact the performance of these devices. And there is a link. This is how far this goes back. January, February of 2010. January, February of 2010. I just put a link to an article, and ignore the first picture on the cover, please. But it is a out of IAEI, and it's UL question corner. And the question was, I have noticed that arc fault circuit interrupter circuit breakers tend to be warmer to the touch than regular circuit breakers. Now that the 2008 NEC requires most circuits in a dwelling to be protected by a combination type AFCI, and there will be more AFCI stacked into a panel, will the added heat affect the operation of the circuit breakers in the panel board or create a hazard? And the short answer is no. So, and this is UL Corner, and they talk about UL 67, they talk about UL 489. Those are all great aspects to understand, and the references and how these things are tested. And I still get this question today. Here we are in 2021. 11 years since this article has come out. And I know there are other reports available that speak to this. And I'm just looking because I know we did some testing. You know what I did was I put temperature sensors inside of panel boards in Arizona, Mexico, New Mexico, California, very hot portions of the country, and our employees' homes. Excellent, Robert Osborne, and so we I'm live right now. Call you after 14 point. Okay. So I did some analysis and I put these temperature sensors, which were basically data loggers, and I did it for 1 year, which was really cool because I could not wait. I mean, I waited a year. I'm not a patient person. I wanted to, and there was no readout. The way that product worked, and I don't think I have it here. The way that product worked, no, I don't. It's over in the other room. The way that worked was you just basically set something, and I put it inside the panel up high, and it was battery, so it had a battery in it, and it did all you did was just put it inside the panel, and it recorded every so often the heat inside of a panel board or wherever you put it, and then what you do is you would take it out, and you would put one of these USB conductors, one of these little USB connections, and you plug it in, and you would download the data into a spreadsheet. And then I combined all of that data into one large spreadsheet, and I did a trend of the temperatures inside of a panel board because I had two reasons. One, these all had AFCI circuit breakers in them, and I had our employees make sure they took note of any tripping that they had for that entire year on their circuit breakers. And if they did have a trip, I wanted to know what their resolution was. Did they simply reset it? Did they find a problem, etc.? We did have some reports of found issues within units, but very few tripped. I'd say maybe I can't even remember, but it was maybe I would say almost as one or two items where they had a tripping circuit breakers. They did find a problem and they fixed it. But so I gathered that data for a year, and I looked at two issues. One, I wanted to see those who had hotter panel boards, did they experience tripping? And those who had cooler panel boards, did they experience no tripping or less tripping? I didn't see any change, any difference. There was I didn't have tripping reports. I didn't have anybody saying that they had all these issues from a tripping perspective. And the range of temperatures was there. So I did not have any issues in that regard. I also wanted to just see what was the maximum temperature and did I exceed the rating of a circuit breaker in these locations where you have a panel board on the outside of the house in direct sunlight. Am I exceeding the temperature limitations of these circuit breakers? And I did not. I expected to see much higher temperatures than I did. And I know those units were calibrated, so don't go there. Steve Froming in the house. I'm not sure what you said. You know that from personal experience. LOL. I'm not sure what that was about, but in any case, so if you run into a case where you have somebody saying that it works for them to put a standard thermal mag breaker in between their AFCIs, you know what? If it works for them, don't discourage them. Don't bleed on their parade. Don't make them cry and think that they've been doing things wrong all these years. If it works for them, it works for them. It could be, I don't know. Just if it makes you feel good, do it. But don't think there's a technical reason for it. All right. So, and I thought there was something else from UL on here. There's testing. The other thing is the indicators. This is the AFCI protection device testing and certification. There's a web page. I'll put that out there too. Because what we say about AFCIs is going to have to be said about GFCIs as well. GFCI circuit breakers, they may not have a microprocessor like these devices do, but they do have technology inside of them. They're longer devices, just like these are. Well, and now things got shorter, so I'm old. Just give me a break. AFCIs, okay, so that's that. So temperature of the devices. Don't worry about the temperatures. If you do have concerns, always reach out to the manufacturer. I have, as I'm sure every other manufacturer has, a document to address this question. Because remember, if you have the question, quite frankly, others will probably have the same exact question. All right. So the other one that came out, another question. So heat rise, AFCI trip codes. Now, so every manufacturer these days has a way to tell you why one of these devices tripped. They'll be done through LED lights, flashing codes. Follow the manufacturer's instructions on how to read those codes, because they're not the same for everybody. Identical. No. Siemens will do it different than Square D. Square D will do it different than GE. GE may do it different than Eaton. I wouldn't say any one of those are the right way. You get the data that you need to help troubleshoot these circuits, but look at the trip codes, look at the LED lights. Some will have more trip codes than others, but leverage those technologies, and just remember they're different between manufacturers. It's not driven by a standard. All right. The other one, we had a discussion about circuit breakers inside of a panel board. Okay. Let's say, for example, when you have a circuit breaker let's just first do this. When you have an assembly, I don't care what the assembly is. It could be a panel board, it could be a switchboard, industrial control panel, switch gear. You can't look at what's internally to that piece of equipment through the eyes of the NEC 100% of the time. And here's why. I'm in a controlled environment. I can do things as a manufacturer of an assembly that you would not be permitted to do in the field. A good example of that is the types of wire that we permit inside of a piece of equipment. And you may say, how could they use that wire with that overcurrent protective device routed where it's at? There's no protection, there's no conduit, there's no raceway. They're violating Chapter 3 rules, Article 240 rules, Chapter 6 rules, whatever, inside that panel board. But remember, there is this little sticker on that equipment. Put it this way. I hope there's this little sticker on that equipment that says it was evaluated to a standard. That evaluation is what helps ensure the integrity and safety of the solution. So we're going above and beyond, and we're getting reviews by third-party agencies that basically look in that enclosure and look at how you're doing what you're doing, they have a set of rules. And there are provisions that I can do certain things when I'm in that enclosure because I'm in a controlled environment and I'm following specific rules. So you can't look at the code and apply it to the solution inside. What you have to do is look at the standard and then apply that to what you are seeing. So, and I've seen this before where we may have, say, for example, a circuit breaker, say, in a panel board serving energy monitoring equipment, surge protective devices, or other types of solutions. And we'll grab the code book, which is an easy thing to do. We grab the code book, we look at definitions, we look at code requirements, and then we try to apply those to what we see inside of an enclosure. And that is just going to lead you down the wrong road. And I'd say, I say it leads you down the wrong road. For the most part, you're probably going down the right road. But you have to understand that there are times when you're looking in a piece of equipment, the well-traveled road has little offshoots. You may be permitted to do certain things in that controlled enclosure environment based upon the standard that you would not be able to do in the field using this book. So whenever you're looking at an assembly, if something doesn't smell right, contact the manufacturer and ask them about the application on whether or not it's permitted, whether it is permitted or not per the standards. If you're not satisfied with what the manufacturer has told you, then you file a report with the standards organization that has applied their sticker. If it's listed. If it's not listed, no holds barred. If it is not a listed solution, then yes, you have full reign. You need to figure out what is right and what isn't right. If it's not a listed piece of equipment, like say a transfer switch, and it's not listed, and they're using wire in there that is used in listed equipment, but wouldn't be permitted by the National Electrical Code, but it's in this unlisted equipment, you would have to say, I need to understand the bigger picture. You may need to get, that's why we call them what? Field evaluations. By who? A field evaluation body. And what are they going to do? They're going to grab the standard for a transfer switch or for a panel board, for a switchboard, for a motor control center, whatever it is. They're going to grab those standards and they're going to look at everything big picture wise. And they may say, yeah, you know what, that is gray SAS wire, and yes, it's this, it's that, and yeah, it doesn't meet the National Electrical Code requirements, but because of all these other things, it's permitted. You just don't know what all those other things are. I don't know what all those other things are. So you have to ask the right questions, and you're going to look for a listing mark. It doesn't mean you can't question what's inside. When you see the listing mark, if you do see something that is questionable, ask and reach out. Circuit breaker inside of a panel board. You may say, well, I removed the dead front and I see a circuit breaker inside of a panel board. And why is it not accessible? And is that permitted? It is permitted to have a circuit breaker inside of a panel board that's not accessible through the dead front. And I'll give you an example of that in the UL standards. If I look back in UL 67, just to give you one example, just one example, and 67 is a long document, and I think it's 6.2.3. 6.2 says equipment on the supply side of the disconnect. 6.2.1 says only the following equipment shall be permitted to be connected to the supply side of the service disconnect, and they go through A through G. And I can tell you that those probably align very closely with what is in Article what? What article covers service equipment? Article 230. There's 220, 225, 230. Special conditions, overhead conductors, building, wiring methods, underground service entrance conductors, minimum size and opacity. I should know this section off the top of my head, and I should not be digging. 230.82. 230.82. Only the following equipment shall be permitted to be connected on the supply side of the service disconnecting means. So you would think that what is in the standard will align with what is in the code. Now, it says in 623, disconnects and overcurrent protection, which are located on the supply side of the service disconnecting means and are installed as part of the equipment, and the circuit being controlled is contained within the panel board enclosure, may be located behind a dead front or screwed on cover that is only intended to be removed by a qualified person. And then there's a marking requirement. So you may open up a piece of equipment and see a circuit breaker inside that is serving equipment in the enclosure that's not accessible through a dead front, that's only accessible through removing a panel to get to it. And when else do we do that? Industrial control panels. We do that in industrial control panels. We will do that in other types of equipment. And again, when it's going to be accessed by a qualified individual. Hey, it's Eddie's cousin, not R. Kelly. That's right. Did you check out that video? I'm telling you, you got to check that video out if you like man caves, if you like hunting. I mean, that's the other thing too. We got to be careful these days. Some people don't like to go out hunting, but my family always has and probably always will. And I haven't recently, but my cousin Eddie has quite a man cave. So you guys got to check that link out. I put that out there already. I just went live really quick. So it's on my YouTube channel and there's a link to it. I don't have his man cave, but I have a link to that. So it's Eddie's cousin. Crazy Eddie's insane. All right. So not R. Kelly. He don't shoot Bammy. Gotta love it, man. Gotta love it. Okay. So, remember panel boards, switchboards, switch gear. You may have overcurrent protective devices that aren't accessible. They may, and if they aren't, and if it's a listed solution, they're permitted by the standard. We can't apply this book to what's in a listed enclosure, right? So where do we have that covered? Right, we have that covered in, I think it's 110.3, examination, identification, installation, use. 110.3a, in judging equipment, considerations such as the following shall be evaluated: suitability for installation, use in conformity with the code, mechanical strength, wire bending, electrical insulation, heating effects, all these other good things. B, installation and use. Equipment that is listed, labeled, or both shall be installed and used in accordance with any instructions included in the listing and label. C, listing. Product testing, evaluation, and listing shall be performed by recognized qualified electrical testing, etc. Right? That's in 110. So read 110.3. 90, Article 90 as well. I know you guys are probably just like me. Article 90 is the introduction. We never read the introduction, right? So, but we have to. 90.2 covers the scope of this book. Very important. Now, 90.4, enforcement. This code is intended to be suitable for mandatory application by government bodies that exercise legal jurisdiction over electrical installations, including signaling and communication systems, and for the use by insurance inspectors. The authority having jurisdiction for enforcement of the code has the responsibility for making interpretations of the rules, for deciding on the approval of equipment and materials, and for granting the special permission contemplated in a number of the rules. Now, you take an enclosure, an assembly. Everything about that assembly has to be approved, right? This code may require new products, constructions, or materials that are not yet available at the time the code is adopted. In such event, the AHJ may permit the use of products, constructions, that comply with the most recent provisions, additions, blah, 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 blah. The inspector has to approve the installation. And if you're looking at a piece of equipment, how do we do that? They may rely on the listing mark and the fact that you didn't modify or adjust it to say they approve it, because they understand that when you have a listed product, it goes through a process and it gets reviewed and approved by a third-party organization. And what I'm looking for is, I'm looking for a specific language, and I'm not finding it. 90.7. 90.7 is, I think this is it. For specific items of equipment and materials referred to in this code, examinations for safety made under standard conditions provide a basis for approval where the record is made generally available through promulgation by organizations properly equipped and qualified for experimental testing, inspections of the run of goods at factories, and service value determination through field inspections. This avoids the necessity for repetition of examinations by different examiners. So I have a UL product, it's listed, it's been reviewed, it's been examined, it's listed, and it hasn't been modified. I don't need to redo that over and over by different bodies. Frequently with inadequate facilities for such work and the confusion that would result from conflicting reports on suitability of devices and materials examined for a given purpose. It is the intent of this code that factory installed internal wiring or the construction of equipment need not be inspected at the time of installation of the equipment, except to detect alterations or damage. So you open up a panel board, you see a circuit breaker inside. It is a listed piece of equipment. You need to determine that breaker, whatever it's serving inside this equipment, was it added after the fact? Is it a part of the manufacturer's? Is it in the instruction? Is it in the diagram from the manufacturer? If it is, and it's a listed product, it's following the rules of the standard. If you don't like it, if you don't think it's right, then you contact the standards body. You can tell the manufacturer as well and say, hey, I don't like this. And they tell you, hey, look, we're designing it per the standards. It's working. That's the way you got to get, that's the way you address that. I've spent these past 2 weeks mitigating a cyber ransom attack on computers and control systems. They got in. We thwarted it. I'm tired, and it took 2 weeks to get it done. Wow. Hey, Robert from Omaha. That's incredible. You know, cyber ransom attack. Hopefully it wasn't in your facility. I mean, was it a customer or what? That's terrible. I tell you what, I would not. I don't wish that on my worst enemy. I know a few people that have been through the ransomware stuff. I tell you what, if they want to take ransomware on my little get together here, they can have it. I'll buy another hard drive. I don't care. I mean, I don't keep anything on this computer worth anything. There's no data that I'd be worth paying anybody for. I just throw the hard drive away and pull another one out. But if you had something of value, that is cybersecurity is a threat to our data, to our electrical distribution systems. In fact, it is a point of discussion in the National Electrical Code. Article 110 is going to recognize cybersecurity threats. Article 240 is recognizing the threat of cybersecurity. I'm not sure what's going on in Article 700, 701, and 708, but I believe they have requirements. I'm not sure if that'll stand the test of time. Nikolai Tesla, good day, everybody. And I'm pretty much done anyway. It's 5 minutes till, so I know I got started a little bit late, but I do have other things to do. So circuit breakers and a panel board, my message there is go back to the manufacturer, look at the standard, make sure it's a listed assembly. Look for that mark, the nationally recognized testing laboratory mark. Make sure it's authentic. Make sure that no modifications were made to the equipment after the fact. And if you don't like it, then put a ticket in with the nationally recognized testing laboratory. We talked heat rise inside of a panel. We talked about the AFCI trip codes. We talked about AFCIs and GFCIs and the perception of heat. We also answered a question about mold resistant and whatnot circuit breakers. And we talked about that you want to make sure that circuit breakers, fusible disconnects, all these great things, make sure the enclosure is suitable for the environment. And I think for a Q&A Friday on Thursday, that's what I've got. Check out my cousin Eddy's video. It's out there. I think you might enjoy looking at some of his trophies and his experience in the whitetail buck world. I have my rack. I've got mine right here. You know where I got this at? Cabela's. See, he goes all over the country looking for whitetail, sitting in trees and all that good stuff. I just go down to Cabela's and I get mine. Piece of cake. All righty. Thank you. Thanks as always. Thank you, Nihad El Sharif, for joining in too. I saw some emails from you. I'm going to get on those here shortly. And Robert from Omaha. Oh, wise one. I wouldn't go that far. I'm Bill Snyder, William Snyder, Felix Sandoval. Thanks for joining in. Hey, there's Nihad. I didn't see your note up above. It was right before. Hola, buenas tardes. ¿Qué pasa? Muy loco la cabeza. Muy loco la cabeza. Great session. Thank you. And I appreciate you dialing in, Felix Sandoval. Yeah, you see the family resemblance. Thank you. Oh, we got Pratik Shah. Thank you for joining in. And Robert and all this crew. Excellent. Excellent. All right. Gentlemen, go get your cup. Next week, so I won't be going live tomorrow. Next week on Tuesday, check out IAEI News Live. And I'll probably do a session, but I think next Friday is Christmas Eve. I think. I don't even know. I don't even know times of year. Is it next Friday? Yes. Next Friday is Christmas Eve. You will not be seeing me do Q&A live on Christmas Eve. You're the man, Nihad. I appreciate you. I appreciate you. Appreciate you very much. So I will be going live on Tuesday next week, the 21st, for an IEI News Live for a holiday week. We just did one last Tuesday, and we talked about holiday safety. I'm putting my program together for next Tuesday as well. I'm not going to tell you what it is yet, but you got to tune in. And I will probably do something. I'll do a Q&A Friday on Wednesday. I don't know. Stay tuned. Subscribe. That's the key. Always subscribe. Make sure you subscribe. Hit the bell. You'll know when I go live, and it'll always be up there for you. Check it out. Q&A Fridays aren't just Fridays anymore. So please stay safe, and hopefully you got something. We learned something together out of this one. All right. So I'm going to jump off and get some work done because my lunch is now over. Thanks for joining in. Thanks for all that every one of you out there do for electrical safety and the electrical industry. Very important to me and each other because we keep each other alive in a very dangerous world where the dangers are hidden. We can't really see electricity. What is the clearing time for reindeer? Robert from Omaha, the clearing time for reindeer depends on the height of the building. That's all I'll say. Thanks. Stay safe. Take care. Stay safe. God bless. And please stay healthy. Take care, Robert. Felix.